Simulation theory usually circulates online as a collection of strange anecdotes. People point to weird coincidences, an intense feeling of déjà vu. No conversation stems from a piece of reasoning. It is a strict, uncomfortable mathematical argument that asks us to calculate the future of computational power. Humans have worried about deceptive reality for thousands of years. Thinkers like Plato asked whether our everyday appearances might be entirely misleading. Then, in 2003, the focus shifted. Instead of a broad skeptical thought experiment about dreams or evil demons, the question became a precise probabilistic calculation about technology, consciousness, and the trajectory of intelligent life. This new framing forces an arithmetic trap. By simply counting the potential number of conscious minds in the universe, it demands that you accept one of three highly unsettling futures for our civilization. The trap was built by philosopher Nick Bostrom. His logic starts with a single premise. If a civilization survives long enough to reach technological maturity, it will eventually harness vast computational power. With that power, they could create ancestor simulations. These would be detailed digital models of historical beings, living out histories with full conscious experience. This diagram shows a theoretical ratio between two kinds of minds. If running these conscious simulations is relatively cheap and easy for an advanced society, they might run billions of them. Very quickly, the multiplying wave of simulated observers vastly outnumbers the few original biological ones. If there are billions of simulated minds for every single biological mind, basic statistics suggests an uncomfortable probability. We should expect to be among the simulated majority. This leads directly to Bostrom's trilemma. If you want to deny that we are currently living in a simulation, you have to choose one of the other 2 points on this triangle. Either human civilization will go extinct before reaching that technological stage, or advanced posthumans will completely abstain from running ancestor simulations. The entire trap rests on a few heavy assumptions. First, consciousness must be substrate independent. Substrate independence is the idea that a mind can operate on any hardware, meaning a digital system can produce the exact same conscious experience as a biological brain. Second, the physical limits of computation must actually allow for this kind of scale. Modeling entire historical worlds and billions of individual human minds requires extreme infrastructure and energy resources that may exceed what physics permits. Third, the argument relies on anthropic typicality. Anthropic typicality is the mathematical premise that we should reason as if we are a random, average sample drawn from the total pool of all possible human-like observers. For the simulation hypothesis to hold, all of these speculative bets must cash out in the exact same direction. If even one of them fails, the math collapses. Critics argue against these pillars. Some attack the typicality step, arguing that we have no mathematical right to assume we are randomly sampled from a vast hypothetical pool of digital beings. Others question the motivation. Even if a mature civilization has the power, they might view creating billions of suffering, conscious beings as highly unethical, or they might avoid it because testing such simulations carries existential risks for their own systems. Physicists like Sean Carroll point out a computational nesting problem. If simulations can contain their own nested simulations, the hierarchy eventually has to bottom out at a physical layer that lacks the power to render any further worlds. These objections keep the debate entirely open. It remains an active dispute about the physical limits of technology and the nature of mind, rather than a closed scientific case. Because it is a dispute about probability, we cannot settle it by hunting for visual glitches in everyday life or pointing to the strange behavior of quantum mechanics. Physicists have occasionally proposed real-world tests, like looking for specific cosmic ray signatures, but those experiments only target highly primitive, naive simulation architectures. A truly advanced post-human simulator would be much more sophisticated. It could use compression, fake its outputs, or selectively render its details only when an observer directly looks, perfectly hiding its tracks. So a lack of obvious digital artifacts does not disprove the theory. But at the same time, the ordinary weirdness of daily life does not prove it either. If we did somehow learn the theory was true, The metaphysical consequences are often misunderstood. Philosophers like David Chalmers argue that living in a simulation would not make your life a meaningless illusion. The physical objects you touch, the moral choices you make, and the actual human suffering you experience would remain completely real and deeply consequential. Instead of erasing reality, the simulation hypothesis simply redefines what reality is built on. It proposes a discovery about the underlying computational substrate of our universe, rather than a negation of our existence. The value of the simulation argument is not as a hunt for hidden source code. It forces us to clearly define what we believe about the nature of minds, the survival of civilization, and what intelligent life will eventually do with extraordinary power.